Dear students, welcome to my channel. Topic of this video is evaluation of information retrieval and subtopic is rank retrieval evaluation. Variety types of metrics is used for the rank retrieval. Now in this video first 4 are covered and remaining is covered in the next video. Now let us start. There are two types of evaluation for information retrieval, unrank and rank. I have already published the video on unrank retrieval. Now in this video we are going to concentrate on the rank retrieval. It evaluates how effectively a system ranks relevant documents higher than the less relevant ones. It typically involves a matrices like average precision, interpolated precision, 11-point interpolated average precision, sensitivity, specificity, ROC curve, cumulative gain and NDCG. It emphasizes on relevant prioritization. Precision recall and F measures are set-based measures and which are used in the unranked retrieval. Their rank is not imported. They are computed using unordered set of documents. Now we want to extend these measures for the rank retrieval. Appropriate sets of retrieved documents are naturally given by top K retrieved document. So this is very important. Here we are considering the top K retrieved documents which are most relevant. Now different metrics which is used for the rank retrieval. So first is average precision. Average precision is a popular metric used to evaluate effectiveness of rank retrieval system. It considers both relevance as well as their ranking order. Average precision takes the entire ranking into account. It used in IR like evaluating the IR system on benchmark dataset, comparing different ranking algorithm and optimizing the retrieval model to improve their ranking performance. Now we will see how to calculate the average precision. Now these 6 relevant documents are there. We are using the ranking. In ranking the 7 documents get retrieved, but out of that 7 documents only 5 are relevant and 1 relevant document is not retrieved here. Now we want to calculate the average precision. So as 6 relevant documents are there, so denominator is 6. And here we require to take the different recall, and at each recall we require to take the precision of at that recall. Now here this is relevant document, this is relevant document, this is relevant document, this is. Now how to calculate the recall and precision I have already explained in my previous video. Now at point 17 we are getting 1, at point 33 we are getting 0.67, at point 5 we are getting 0.67, 0.67 we are getting 0.8, then 0.83. Now one relevant document is not retrieved here, so that's why we are putting 0. So we are taking this as an average and the value is 0.675. Now we will see the next example. Again here 6 relevant documents are there, but only 4 documents are retrieved. So we require to take this recall value, and at that recall we require to take the precision. Now here 0.17 precision is 0.5, 0.4, 0.5, 0.57. These 2 extra zeros are there because total 6 relevant documents are there, only 4 gets retrieved, so 2 relevant are not retrieved, so we are keeping there 0 0. So we are again taking the average, and average is 0.328. So in this way we are calculating the average precision. But when we calculate pure average precision, at that time whatever the relevant documents which is not get retrieved, we are taking their weightage as a 0 0. Precision recall curve. For each such set, precision and recall values can be plotted to give the precision recall curve. Precision recall curves have a distinctive sawtooth shape. So reason for that shape is if k+1 documents retrieved is non-relevant, then recall is same as for the top k documents, but precision has dropped. But if the next document is relevant, then both precision and recall is increases. That's why the curve jags up to the right. So this results into the distinctive sawtooth shape. So when we want to compare, at that time this is a disturbing because it looks like this. So instead of that we want the value in a interpolated. So when we plot the value in interpolated fashion, we are getting such type of shape which is represented in a red color. To obtain this we require to use interpolated precision. So interpolated precision in the literature there are 2 formulas. One is r dash is greater than or equal to r, and one is between that. For r we are taking between rj and rj plus 1. So interpolated precision I will explain with the example, because it is very easy to understand with the example. Now again we will take this ranking one, 6 documents. This is nothing but there are 7 documents gets retrieved. Now this is recall and precision we already calculated. Now how to calculate the interpolated precision? Here r dash is greater than or equal to r. Now this is our recall level, and at this recall level we require to check all the next recall level, and where the value is most we are replacing that value. Now one is the largest value, we will keep one here. Then now 0.33, from this recall level we will check all the next recall level, and at that recall level we check the precision value. Now again the largest precision value is 0.83, it is replaced. For this largest is 0.83, so in this way 0.83 is replaced. So this is original, and we are getting this value as a orange answer by first method. By second method we require to do with the value between that level and the next recall level. So 0.17 we will consider the 1 and 0.67, then we will get one value because 1 is large. For 0.33 we will consider the 0.67, 0.75 we will get 0.75. For 0.5 we will compare this value, we will get 0.8. For 0.67 we will get 0.83 value, and for 0.83 it is a 0.83. So in this way we are calculating the interpolated precision. So two ways are there. Now we will see the next example. Here recall, and we require to take the precision. Now for this recall we will consider all next recall level. The maximum value is 0.57. For this 0.57, so in this way 0.57 is replaced, and here we take this value, 0.5 is larger, 0.5 is larger, 0.5 is larger, 0.57 is larger, and last value is 0.57. So in this way, by two ways we can calculate interpolated precision, and any one of the way is okay when we want to go for the next method. Now see this, the next problem, and I am not going to explain, but you should just watch this slide and try to find out the interpolated precision by the two methods. .11 interpolated average precision. How to compare two models by precision recall curve. Solution is 11 interpolated average precision. So here we are taking the recall values from 0 to 1, and when we take the 0 to 1 at interval of 0.1, total 11 values are there. So when we want to compare the two systems, we can take recall level from 0 to 1, so total 11 values are there, and for two systems we will compare at each recall what is their precision. So in this way 11 becomes a standard way to compare the two systems. Now here I will give the example that how we are calculating the 11 system. Now this is the number, this is not recall, this is actually ranking. Ranking is there, or you can write down the number. Now here we require to take the recall from 0 to 1, so 11 points are there. Now this is the recall 0. Now we are not taking the precision into the consideration, but we are taking the interpolated precision. So first we require to convert precision to the interpolated precision. Now here for recall 0 or 0.07, 0.07, all values are 0.5. So this is the simplest example. In the next example you can find out how to write down in a perfect way. This is the simple example. Now here we can check that the value 0 we can write down 0.5. Now next value is 0.10. Now 0.10 is not here, but below 0.07 is there, so we are taking that value 0.5. Next value is 0.20. Now for 0.2 directly here, so we are writing the 0.5. 0.3 is not here, so from the 0.3 onwards we are getting the 0 value. So in this way we can write down the value in 11 interpolated precision. Now here we can check easily. Now recall is converted, this is number, or you can say ranking also. So this is the we are not taking this value into the consideration, we are taking this value into the consideration. Now here recall is between 0 to 1, 11 sub points are there. Now for next we can see that 0.25. so in the 0.25, 0, 0.10 and 0.20 is included, so we have written directly 111. Now this 0.25, so for 0.30 we can't consider the 0.25, we require to take the next interval 0.50. so for 0.50 it is a 0.67, so 0.30, 0.40, 0.50 it is replaced by 0.67. Next is the 0.75. so for 60 and 70 we require to take this 0.75, which is nothing but 0.6. Again after 0.75 it is directly 1, so for 8, 9 we are taking and 1 we are taking the 0.4, 0.4, 0.4. so in this way we can write down the interpolated precision. Next measure, and which is very much famous, is mean average precision. It provides a single figure measure of the quality across recall levels. Among evaluation measures, MAP has been shown to the good discrimination and stability. For a single information need, average precision is the average of precision values obtained for the set of top K documents existing after each document is retrieved, and this value is then average over the information need, which results into the MAP. Now see this mean average precision, but when we calculate only pure average precision, at that time for that the document which is relevant and not retrieved, we are keeping the 0, but when we calculate the mean average precision, at that time we are not taking that value 0. so just understand the difference between when we purely calculate average precision and mean average precision. Now this is the ranking 1, this is the ranking 2. Now rank 1, 10 documents retrieved, rank 2, 10 documents retrieved. I have just keep the relevant documents, so this is the relevant. So relevant occurs at 1, 3, 6, 9 and 10. To precision you require to take 1 relevant, total 2 relevant, total 3 relevant, total 4 relevant and total 5 relevant, and in the denominator that number of documents retrieved will come. So 1 document retrieved, 3 documents retrieved, 6 retrieved, 9 retrieved and 10 retrieved. So in this way you calculated the precision at that particular relevant document retrieval, and we take simply average, and we are not taking 0 others into the consideration. And this is nothing but the for the ranking 2, only 3 documents are relevant at location 2nd, 5th and 7th. So denominator 2, 5, 7, 1, 1 plus 1 2, 1 plus 1, 1 plus 1 plus 1 3, so it is nothing 0.43, average is 0.44, and when we take the average we are getting 0.53. For the second example, now these 20 documents get retrieved. Now this is at first location 3rd, 6th and 10th and 20th. We can easily calculate the precision. Denominator is 1, 3, 6, 10 and 20, and numerator is nothing but the total number of relevant documents retrieved. So in this way we calculate the average, and for the rank 2 15 documents get retrieved, this and this. Denominator is 1, 3 and 15, numerator is 1, 2, 3, and their average is 0.623, and by this way we get the mean average precision. Now see the next example. Consider the following search results for the query Q1 and Q2. These 10 documents get retrieved, and this highlighted are the relevant documents. So for the first 5 documents are relevant, and for the second 4 documents are relevant. Find the map for this query. Find the R precision for Q1 and Q2. Calculate the precision recall at 10. So we will solve problem one by one. Now find the map for this query. Now for the first Q, 5 documents are relevant, and for the second 4 documents are relevant. So this is D1 to D10, relevant location, their precision, we calculate the average. Then in the numerator 1, 2, total 3, total 4, total 5 comes, and denominator is nothing but the total number of documents get retrieved. So this is nothing but the for the Q1, and this is for Q2. And when we represent the problem in this such in table manner, it is very easy to calculate also. So 0.77, this is 0.64. Again we will take the average of both to get the mean precision average. Next is to find out the R precision for Q1 and Q2. Now R precision, R is nothing but the how much that relevant documents are there. Now here for Q1 5 documents are relevant and for Q2 4 documents are relevant. So we require to take the precision at this R value. So for the second for the Q1 relevant documents are 5, so we are taking the precision at the 5th level, and for Q2 the 4 documents are relevant, so we are taking the precision at the 4th level. So this is nothing but the answer. Calculate and precision at 10, that is precision at 10, recall at 10, using the concept of TP, FP, TN and FN, and we can represent. So I have already took lot of problems on this type, so I am not going to explain again. You just observe the problem and you try to complete the table. So for Q1 total 5 relevant documents are there. All 5 get retrieved, so this become 5. No document is false negative, and out of 10 only 5 are relevant, 5 are not relevant, so they are retrieved. So this is 5, so we can easily calculate precision is 5 by 10 and the recall is 5 by 5. Here recall value is 1 because in the system 5 are relevant documents in the collection and all gets retrieved. But when we get retrieved that 10 documents, only 5 are relevant, 5 irrelevant document also we get. So that's why precision is 0.5. Now for the second system 4 are relevant and all 4 gets retrieved, and therefore false negative is 0, and with the relevant 6 irrelevant documents gets retrieved. So this is the 6, and when we calculate the precision we are taking this row, that is 4 divided by 4 plus 6, that is 10, and when we are taking this recall we are taking this row, that is 4 by 4, which is equal to 1. This is the R precision. Even we can find out the precision at K particular value. Precision at K and precision recall at K. So here we calculate precision and recall at 10th, so only we can replace K with a particular value, and at that particular point we find out the precision at K and recall at K, because this is important for the rank retrieval, because users are not interested to see all the documents. So when to use precision at K and recall at K, it's a way to measure how accurate the top few results are. It is perfect for web search engine because most people only look at the first few links. So precision at a particular K is very much important. Recall at K, it is a way to measure how many of the total relevant results we found after checking a certain number. It is good for archive retrieval system. For example, historian searching a massive archive of the historical documents for information about World War II. He or she search the archive and get a list of 1000 results ranked by relevance. Recall at 100 would measure what proportion of the total relevant documents you managed to find out within those first 100 results, and recall at 100 is means 50%, which is equal to 0.5. It means that 50% of the relevant documents about the World War II within the top 100 results. So this is required when we want to see the success at a particular K value. Precision at the R position in the ranking of the results, that is R relevant documents. So here I have already explained the example of R precision, but here again I will explain R precision because total number of relevant documents in the system. So here total number of relevant documents are 6. So we are taking the precision at the 6th. So at 6, 4 documents which are relevant and retrieved divided by 6, so which is nothing but the 0.67. Break even point. Given a precision recall curve, the precision recall break-even point is the value at which precision is equal to recall. So when precision is equal to recall, it is called as a break-even point. It is obvious from the definition of the precision recall, the equality is achieved for the contingency tables. Here we can see this is TP, this is FP, and this is TN, and which is possible when break-even point is possible when TP plus FP is equal to TP plus FN. So given a precision recall curve, the value at which precision equals to the recall. So this is the formula for break-even point. Now we'll solve the example. Consider an information need for which there are 4 relevant documents in the collection. Contrast 2 system run on this collection. Their top 10 results are judged for the relevance because it is a ranking evaluation of the rank retrieval. Now this is document number 1 to 10. This is system 1 and system 2. 4 relevant documents are there. So 1, 2, 3, 4. Here 1, 2, 3, 4. Now we require to find out the map which has higher map. Does this result intuitively make sense? What does it says about important to getting a good map score? What is the R precision of the each system? So we will first solve this first 3 questions. What is the map of each system and which has a higher map? So 1 to 10, 4 documents are relevant. We will calculate the precision, and I have highlighted the precision at the particular recall at the particular relevant documents retrieval to get the map score. So we are taking the average of 1, 0.67, 0.33 and 0.44 to get the average of 0.6. Here we are taking the average of 0.50, 0.40, 0.50, 0.57 to get this average of 0.49. So system 1 has higher precision because out of 4, 2 documents is retrieved at the initial phase. Here only 1 document is retrieved at the initial phase. Even 5th, 6th, 7th continuously we are getting the correct result, but initially we failed to get the relevant documents. That's why system 1 has higher average precision. What is the important in getting the good map? It rewards for the relevant documents in the beginning of the list and can be seen as a beneficial. That's why even we can see that these documents are continuously, that is up to 7th location we retrieved all documents, but initially we failed to retrieve the relevant documents. That's why the map is low for the second rank. What is the R precision of each system? Now R is nothing but total number of relevant documents. So relevant documents are 4. So we are calculating the precision at the 4th level. So this is 2 by 4 and this is 1 by 4, 0.25. Next example. The following list of R's and N's represent relevant and non-relevant written documents in ranked list of 20 documents retrieved in response to query from collection of 10,000 documents. Now the list shows 6 relevant documents. Assume that there are 8 relevant documents in the total collection. So total 10,000 documents are there, out of which for that particular query only 8 documents are relevant, and here we are taking the system only up to 20 retrieval. So in that 20 retrieval we are getting only 6 relevant documents. So 2 relevant documents are not retrieved in the first 20 retrieved documents. So first question is, what is the precision of the system on the top 20? Now precision is we require to check at this location. So at this location denominator is 20 and up to that 6 document gets retrieved. So 6 by 20. What is the F1 score on the top of 20? First, to get the F1 score we require to calculate the recall. So total 8 documents are relevant in the system. So denominator 8. Out of that 8, 6 we retrieved. So 6 by 8 is 0.75. Now F1 is nothing but 2 into precision into recall divided by precision plus recall. So by applying this formula we can calculate the F score. Now next we require to understand in detail manner what is the uninterpolated precision of the system at 25% of the recall. Now total relevant documents are 8. 25% of the recall is 25% of 8 is equal to 2, means where the second documents gets retrieved. Now I have highlighted this, so you just observe this up to this. So here our first document, relevant documents get retrieved successfully, and at this location second documents retrieved successfully. Now 25% of the recall, because total 8 documents are there, so 25% is 2, so we are taking this particular, and in between we want uninterpolated precision, means as it is. So it is 1, again 1, 2 by 3, that's why 1 1 is not written, 1 1, 2 by 3, 2 by 4, 2 by 5, 2 by 6, 2 by 7 and 2 by 8. So in this way we have to write down the answer. Now next is what is interpolated precision at 33% of the recall. Now again I have highlighted for simplicity. Now what you require to do, total relevant documents are 8. 33% of 8 is 2.64, which is equal to 3. I have round off to the 3. Now when the third document gets retrieved, so when this is the third document get retrieved, now when we take the interpolated precision at that time, by any way, either we can take that recall rate and the next recall rate, and we will take the maximum value, or we will take all next retrieval take and pick up the maximum value. So I have written the precision value for simplicity, and if you observe at this step, we can take this precision value or the next precision value which is larger. So we can observe that even we compare this and next, we can take the 0.36, and even we compare with the rest of this, again we are getting the 0.36. So therefore the answer is 0.36. So for that your interpolated precision concept should be clear to solve this problem. Now next, assume that these 20 documents are the complete result set of the system. What is the map of the query? So here we require to take this, here relevant documents get retrieved, and for that retrieval we require to take their precision, and this is nothing but the average. So we are getting 0.55. If they ask only average precision, so at that time we are taking divide by 8, and whatever that remaining 2 we will take 0 plus 0 and we will calculate. Now for the next subtopic question, you require to observe the problem carefully. Now instead of the system return entire 10,000 documents in a rank list, and these are the first 20 results written, what is the largest possible map in that the system could have, and what is the smallest possible map? Now here what we observe that when we want that good MAP, at that time that document should retrieve immediately. So we make assumption that after 20, 21 and 22 that remaining 2 relevant document gets retrieved, because up to 26 relevant documents get retrieved. For the next 2 they will immediately get at the 21 and 22 retrieval. So we calculated that score, so we are getting the map as 0.503. Now we'll want the minimum map. Minimum map means what? We don't want a good retrieval rate or good precision. So at that time what we will make assumption that after 21, 22 we got non-relevant documents, and at last, that is at second last position, that is 9,900, we get the value relevant documents, and at 10,000 location we get the final our 8th relevant documents. So we are getting this score, and when we take the average we are getting 0.413, and here we can check that this score is higher because all relevant documents retrieved at a very early stage compared to this. In a set of experiment, only top 20 results are evaluated by hand. The result in E used to approximate the range f and g. for this example, how large can the error for the map to be calculated? E instead of F and G for this query. Now for this we calculated in the equation only the plane map, which we found it is 0.35. Now with the largest we found the map with the 0.503, and with the smallest, here we make the assumption that all that relevant documents returned in the last, that is at the 9099 location and the 10,000 location, we get the 0.415. so we require to take the difference between this and we require to take the difference between this. So this is nothing but the error between them. So these are the references used for this presentation. Thank you. So remaining metrics used for the rank retrieval or evaluation of rank retrieval is explained in the next video. Thank you.